Okay.
because of the electrophoresis.
Okay. But
So it's happening like in real time at the same time. So can
okay.
because if I use the one filter, that means I'm losing the other one at the same time because they're
Okay.
moving
Yeah.
together.
I see what you're saying. Yeah. Yeah.
In that case, is there any way that I can use a single cube and
Well,
filter?
you know,
filter?
in your situation, what people typically do with that is they have a microscope with a motorized filter turret that very quickly changes between the channels and automatically, I mean, you know, within like a quarter of a second or so, it switches from one cube to the other, and they can capture those images very quickly, whereas this is a very manual, very slow process. So in your instance, it might be good to get a double band filter cube based on those, so that you can actually you know, capture both at the same time.
Same time, yeah.
Yeah. So, okay. So now that we've got a DAPI in the right side and the FITSI in the left side, you guys are now experts on putting in filter cubes, right?
Totally.
You've seen that. So now you got that down. So there's a couple of things here on the back. This is a diaphragm. Right now it's open and close. And F means field diaphragm. So it's just like a diaphragm on a upright microscope where you're closing down the area of the light that's coming through. So typically keep this in the open position. The only time you would use this is that, you know, if your sample is photo bleaches really, really fast, you might want to close it in on a small area. That way you can get your sample in focus and without photo bleaching the entire field of view. And then also there is this little slider here, so let me take this out and show you what this guy does. So this is something you really never have to worry about. There is like an ND, it's probably a neutral density 8 filter there. See how that attenuates the light? Always keep it in the open position because you have much better control of your lamp intensity here. So this system was designed before we had systems that had the nice iris here that controls the amount of light. So just always keep this guy in the open position. If for some reason it's looking dimmer than it normally looks, make sure somebody hasn't pushed this into the light path. But like I said, you should always keep this in the rightmost position so that it's not in the light path. So I can find this here. And you'll feel that there's, when you have it in position, there'll be like little indentations. You'll feel it. And the other thing too is that if you ever see like a weird shading on your sample, then this is one of the things you check. Make sure it hasn't gotten bumped like part way in or something. So just keep it pushed all the way to the right.
So this is open position right now?
Right, yeah. Because there was no filter in the left and that filter was in the right. Okay, so now we've pretty much covered this guy pretty well. So let's turn on the light there. So just flip that switch on. And this is a 2,000 hour life metal halide bulb. So how many hours does it say? Oh, it's still done its startup here. And pay attention to this little thing here. Only 35 hours. Okay, I didn't use that much. So what you want to do with this is when you turn it on, if you're going to use it for several experiments throughout the morning, then just turn it on in the morning and leave it on. You don't want to turn it on and turn it off frequently because every time you turn it on, it loses about 3 or 4 hours of life. So, you know, if you're going to use it once in the morning and then once in the afternoon, then yeah, turn it off when you're done in the morning. But never turn it off faster than 5 minutes. It's kind of got to warm up and do its thing and before you in turn turn it off. Does that make sense? Mm-hmm. Okay, so we've got this on 100% output. So I'm going to take a look at
So in 2,000 hours, after that you need to change that one?
Right, yeah, after 2,000 hours. Now the 2,000 hours is based on if you use it, you know, 4 to 6 hours at a time. if you're only using it, you know, if you only do one experiment for 10 minutes every day, then it's not going to last you 2,000 hours. So,
Oh,
because again, it loses 4 hours of life every time you turn it on. Okay. Actually, that's not too bad, considering how clean up this is, but you see all the different concentric circles?
yeah.
It should just be one. It will be brighter in the center like it is, but you shouldn't see the concentric circles like we do. So that's an indication that this is,
Because of the band?
yeah, because of how that's been bent. So it's not bad. I think it'll be okay, but just kind of be aware of that, so that that doesn't get bent anymore. And the same thing is true up here. You don't want, that's okay like that. Okay, so let's start off with imaging, and I'm going to take the camera off this guy. So I'm going to actually turn this camera system back off. You never want to unplug the camera with the camera controller turned on, so always unplug that. I can see that lens there has a lot of dust on it, so it's,
Because it was open?
yeah, so it's going to need to be cleaned at some point. So, and let me turn this, rotate this just a little bit. I have some extra drivers, so I'm going to leave you one of these. You're actually missing a screw there. What's going on here? That's odd. You're actually missing both of the screws on this. So, I'm just going to put that in straight like that. It's not catching. It's kind of catching on something. Well, there's not a label there. Huh. It's just not going in right. I don't know why. Something else the service people can look at. Because without that going in all the way down, the camera's not going to be in focus with the microscope. So, don't really understand. It's catching.
Hey.
Hi.
So how is that filter?
Okay, there we go.
Yeah.
Okay.
It's not here, I guess.
Okay.
Next week sometime.
So.
Can I move that?
Okay, so now that we got the camera hooked up to that, we can turn this guy back on. And then let's just look at something here. So on an inverted microscope, of course, you want the cover slip, you want it down. The cover slip always goes between the objective and your specimen. On an upright microscope, of course, you have it like this because your objectives are coming down. See the cover slip's on the top side here? So, cover slip always faces the objective. So, if we want to look at bright field, we can take that out. Make sure the light down some. Okay, so everybody just take a quick turn at looking at that. Just look at it in bright field and then look at it in phase contrast.